Hello, I'm Tianjiao from University of Queensland. Today I'm going to introduce our Cenozoic channel deposits project on behalf of myself and other members in our group, who are Dube, Professor John Esterle, and Dr. Jennifer Cooling. We also acknowledge our sponsor, BHP. The Cenozoic channel deposits cross-cut the Permian-Triassic strata in the Bowen Basin of Queensland. That is one of the major coal-producing regions in Australia. During the Late Cretaceous, the northern part of the Bowen Basin was uplifted and incised by channels that fill with sediments and basalt lava flow throughout the Cenozoic. The basalt are the product of the regional hotspot volcanoes and has been dated as occurrence in two poles, one in the late Paleocene and Eocene, another one in the Oligocene and early Miocene, associated with well-dated spring shore and peak range volcanoes. The Australian Cenozoic was also a time of climate and tectonic change. From the late Cretaceous, as Australia and Antarctica separate, Australia plate moved northward and the climate upwent a series of climate change and went the characteristic modern Australia flora. Due to the channel's intersection with the Permian and coal measures, these channels has been extensively drawn and offer a window into this critical time in the development of the modern Australia landscape. This presentation considers the initial results of a study of two boreholes located 50 kilometers apart, intersecting two of these channels. In the map of the surface geology of the region, the Cenozoic is represented by two sedimentary formations, the Settle Formation and Durango Formation, and a series of basalt lava flows. The Durango Formation is best preserved within the Bowen Basin as a series of interbed oil shale and lignite, which basin was created by Durango faults during the Paleocene and Eocene as a result of corrosive rifting. It is typically mapped to the southeast of the study area. In the northwest, the Cenozoic sediments are typically mapped as the Neogene formation. The sediments of Settle Formation are overall less consolidated than the Durango Formation and largely restricted in occurrence to the Paleocene paleochannels. A number of the basalt flows are often overlying by interbed with these sediments unit. The lava flows are widely distributed in the Bowen Basin and have associated intrusive. The entire region was extremely weathered, and many of the rock at or near the surface has been partially or entirely weathered to the clay, and makes it difficult to determine if they are initially or igneous or sedimentary origins. The distribution of Cenozoic channel is not always contiguous with basalt flows as mapped from the drilling or aeromagnetic data. Channels cut folded Permian strata and resolved into a meandered belt in the southern part of the study area. Dube in her 2019 author series examined those southerly of the two cores from this study, while the north core is currently undergoing study by myself, Jennifer Cooling, and Professor John Esterle. The most basal part of the core intersects Permian Bowen Basin strata, which is overlain by a sandy interval of possible Late Cretaceous age. This is covered by a fluvial or lacustrine sediments that contains pollen of possible Eocene age, which could make Durango Formation equivalent. Overlying that is one first set of the basalt lava flows. Those flows shows papyritic texture as their base, suggesting that if it was not lacustrine environment, the lava flows into soggy, which reflects the Paleocene in Australia was warm and wet, with the climate in eastern Queensland probably being subtropical to tropical. The basalt flow are succeeded by 5 meters of sediments contains palynoflora of eucalypt and great pollen, which makes interpret as Neogene in age, and many are linked to the beginning of the aridification of Australia continent that show a shift to the ice house condition in the Oligocene. Above this interval is another set of the basalt, which have the mix of bohoi and possible paleo-basalt fabric. These are topped by a thin interval of the laterite contains a dry adapt palynoflora of wood pine and dry eucalyptus. The second core is located 50 kilometers to the north and intersects a different channel. In this core, 4 units has been identified. Unit 4, the lowermost of non-Permian units, consists of a breccia and conglomerates that find up to the Unit 3 claystone. The breccia and conglomerate are of laminated Permian siltstone, supported by deformed sand and mud that has been yielded pollen of both Permian and Eocene age. The breccia is interpreted as being a fault scrap-triggered alluvial fan overlying by the conglomerate. These appear to be the age equivalent of the Bowen Basin to the east and lower part of the southern core. Unit 3 consists of the alternating subunit of white claystone and dark carbonaceous siltstone or lignite. These appear to has been deposited in 3 cycles of white claystone, followed by organic rich materials under sub-aqueous condition, which is currently interpreted as lacustrine setting. Based on the preliminary palynology study, samples from this unit appear to be Miocene in age. SEM work has been shows that the clay of Unit 3, they are polycrystalline kaolinites. That is based on their honeycomb or wheelie habit, appear to be produced by alternations of the smectite. Above this sequence is Unit 2, which consists of a mix of orange and gray smectite-rich clay, siltstone, and unconsolidated sands. The clay and siltstone of this interval are highly variable. They commonly rich in goethite, overprinting clay with both kaolinite and smectite, which suggests that the fluctuating water table and subaerial exposure during the deposition linked to the increasing aridity relative to the Unit 3. The sand vary, but in general well-silted and subangular to well-rounded. Their sedimentology characteristic shows more typically of beach or wind deposit. The palynofloras are depopulated, but contains eucalyptus and Cretaceous plant of the Eocene age supported by drying climate. The sedimentology section is covered by 2 basalt floors. The floors has been heavily weathered into thin laterite and appear to be the post-Miocene, which is based on the preliminary pollen study. 2 channels are only 50 kilometers apart, and these 2 cores record a similar palymorphous succession but record different deposition environment with variable volcanic events. Post-Permian deposition in the southern channel began in the Late Cretaceous and continues into the Paleogene or Eocene before deposition of the number of basalt flows. The southern channel does not appear to have begun deposition until the mid-Paleocene and also does not contain the equivalent to the lower part of the basalt of the southern channel, which may not have flowed as far north as later flows. The sedimentary Miocene record in the southern channel is condensed compared to the northern channel, where has a much more extensive sequence has been captured. The transition from Unit 3 to Unit 2 appear to illustrate the changed climate condition of the Australian continent as it moved northward and become drier. Late flow in both core upmost part are weathered into laterite. So the future work will be keep on studying and more detail about the climate change and sedimentary environment in the Cenozoic Bowen Basin. Thank you so much for your interest and attention.